At first glance, the behavior appears unremarkable. In forested regions across South Asia, leopards are frequently recorded standing motionless for extended periods of time, particularly during early morning and late afternoon. Camera traps capture these moments repeatedly. The animal remains still, partially framed by vegetation, its body oriented toward open space, yet making no visible attempt to move, pursue, or retreat. To an untrained observer, this posture is often dismissed as rest or hesitation. To a casual viewer, it may appear inefficient or even accidental. Predators, after all, are commonly associated with motion, pursuit, impact, and decisive action. Stillness rarely attracts attention. However, when this behavior is examined more closely, patterns begin to emerge. The duration of stillness is not random. The timing is not evenly distributed throughout the day, and the environmental conditions in which it occurs are remarkably consistent. These moments coincide with specific light angles, specific background structures, and specific spatial configurations within the habitat. The behavior appears repeatedly under circumstances where visual clarity is reduced, but not eliminated. Importantly, the animal does not retreat into cover. It remains exposed, often within clear lines of sight. Yet detection rates remain low. Observers frequently report delayed recognition, uncertainty about position, or difficulty determining the animal's posture and distance, even when it is fully within view. This suggests that the behavior is not passive. In behavioral analysis, stillness is rarely neutral. It often serves a function related to energy conservation, risk management, or sensory optimization. When repeated across individuals and environments, it indicates an adaptive response rather than coincidence. To understand why this behavior persists, it is necessary to remove narrative assumptions. There is no intention to disappear, no strategy to deceive, only a sequence of observable actions occurring under consistent conditions. To understand this animal, we must move beyond how the behavior appears and examine how it functions. Stillness as a functional state. A. Observable description. Across multiple habitats in South Asia, leopards are repeatedly observed entering prolonged periods of immobility. During these intervals, the animal remains upright or partially crouched, with its body aligned toward open terrain rather than concealed within dense cover. Limbs remain fixed. The head maintains a stable orientation, and only minimal micro-movements, such as subtle adjustments of posture or breathing, are detectable. These periods can last from several seconds to multiple minutes, and they occur without any immediate transition into pursuit or withdrawal. Camera trap footage confirms that this immobility is not associated with fatigue or rest. The posture differs from lying or reclining positions typically linked to recovery. Instead, the body remains structurally engaged, capable of immediate movement. The animal's silhouette remains intact, yet motion cues are largely absent. Importantly, this stillness is not rare or exceptional. It appears consistently across recordings from different regions and individuals. B. Trigger and context. This behavior occurs most frequently during transitional light conditions, particularly at dawn and dusk. These time windows coincide with low-angle sunlight, partial canopy cover, and complex visual backgrounds created by vegetation, uneven ground, and fragmented shadow patterns. The behavior is less commonly observed during midday hours, when overhead light increases contrast and depth cues. Environmental context also plays a role. Stillness is more frequently recorded at habitat edges, near game trails, clearings, or terrain transitions, where visibility is variable rather than uniformly obstructed. These locations provide open sightlines without full exposure, allowing the animal to remain visually present while minimizing detectability. The consistency of timing and location suggests that stillness is not a default state but a conditional response activated under specific environmental circumstances. C. Adaptive function. From an adaptive perspective, stillness serves multiple biological functions simultaneously. First, it reduces energetic expenditure. Remaining motionless conserves energy during periods when immediate action is not required. Second, and more critically, it alters detectability. In visually complex environments, motion is a primary trigger for attention in both prey species and human observers. By eliminating motion, the leopard reduces the likelihood of early detection. Stillness also interacts with sensory limitations of observers. Visual systems prioritize change over static information. When motion cues are absent, attention shifts elsewhere. Even if the object remains within the field of view, this allows the animal to remain exposed without actively concealing itself. Functionally, this creates a temporal advantage. The leopard gains additional time to assess surroundings, monitor prey movement, and determine whether engagement is advantageous. The behavior increases the probability of remaining undetected long enough for other variables, distance, orientation, or lighting to shift further in its favor. D. Limitation and trade-off. Stillness is not without cost. Remaining immobile reduces the animal's ability to respond immediately to unexpected threats. It also increases reliance on environmental conditions remaining stable. Changes in light angle, wind, or background movement can rapidly undermine the effectiveness of immobility. Additionally, prolonged stillness may reduce opportunities for active pursuit, particularly if prey moves beyond effective range. The behavior therefore represents a trade-off between concealment, efficiency, and responsiveness. It is most effective only when conditions align closely with the environmental triggers that support reduced detectability. Despite these limitations, the repeated presence of this behavior across populations indicates that its benefits outweigh its costs under specific conditions. Stillness functions not as inactivity, but as a controlled behavioral state that enhances survival efficiency when visual uncertainty is highest. Trigger conditions and environmental timing. A. Observable description. Leopards do not display prolonged stillness uniformly across all conditions. Observational data from camera traps and field surveys show that immobility clusters around specific times of day and specific environmental states. The behavior appears most often when ambient light is neither fully bright nor fully absent. During these periods, the animal maintains a fixed posture in partially open spaces, remaining visible yet difficult to resolve visually. The surrounding environment, vegetation, ground texture, and shadow distribution appears visually active, while the animal itself contributes minimal change to the scene. Notably, the behavior diminishes during periods of stable, high-contrast lighting. Under strong overhead illumination, leopards are more likely to either retreat into cover or transition into movement. This contrast suggests that stillness is not a generalized default, but a response calibrated to external conditions. B. Trigger and context. The primary triggers for this behavior are environmental rather than internal. Low-angle sunlight at dawn and dusk creates elongated shadows, uneven illumination, and reduced depth clarity. In forested or semi-forested habitats, these effects are amplified by canopy filtering and irregular terrain. Visual scenes become fragmented, with multiple competing edges and overlapping textures. Under these conditions, visual systems, both human and animal, experience increased difficulty in isolating static forms from background noise. Stillness becomes effective precisely because the environment itself generates constant visual variation. Leaves move, light shifts, and shadow boundaries fluctuate. Against this backdrop, a stationary body does not register as salient. Spatial context further refines the trigger. Leopards are more likely to adopt stillness near transitional zones, such as forest edges, trail intersections, or areas where ground cover changes abruptly. These locations maximize background complexity without fully obstructing sightlines. The animal remains in a position where observation is possible, while detectability remains low. C. Adaptive function. Functionally, responding to these trigger conditions allows the leopard to exploit predictable weaknesses in visual detection. The behavior aligns with moments when observers rely most heavily on motion and contrast to identify threats or opportunities. By remaining motionless during these windows, the animal reduces the likelihood of early detection without expending additional energy. This timing also increases informational gain. Stillness permits continuous monitoring of prey movement and environmental change without drawing attention. The leopard can evaluate distance, direction, and density of potential targets while maintaining a low detection profile. In this way, stillness functions as an information-gathering phase rather than a passive pause. From an evolutionary perspective, behaviors that synchronize with environmental conditions tend to persist because they increase efficiency without requiring anatomical change. The leopard does not need to alter its physiology to benefit from low-angle light. It only needs to adjust timing. This makes the behavior flexible and broadly applicable across habitats where similar lighting conditions occur. D. Limitation and trade-off. Reliance on environmental triggers introduces vulnerability. If lighting conditions shift rapidly due to weather changes or canopy gaps, the effectiveness of stillness decreases. Sudden increases in contrast can restore depth cues, making the animal more detectable. Additionally, remaining stationary in transitional zones exposes the leopard to potential counter-detection by prey species that rely on non-visual cues such as scent or sound. There is also an opportunity cost. By waiting for optimal conditions, the animal may forego immediate opportunities that require movement. The behavior, therefore, represents a balance between exploiting predictable perceptual limitations and maintaining responsiveness to changing circumstances. Despite these constraints, the repeated alignment of stillness with specific environmental triggers indicates that the behavior provides a consistent, adaptive advantage. It persists not because conditions are perfect, but because they are frequent enough to make timing-based concealment biologically efficient. Visual detection and the absence of motion cues. A. Observable description. When leopards enter periods of stillness under low-angle light, observers consistently report difficulty isolating the animal from its surroundings. In recorded footage, the animal's outline remains visible, yet its body does not immediately register as a distinct object. The background, composed of foliage, ground texture, and shifting light, appears visually active. While the leopard contributes minimal change to the scene, the animal's posture remains stable, and no obvious movement cues draw attention to its presence. This effect is most noticeable when the leopard occupies a visually complex background rather than uniform cover. The animal may be fully exposed within the frame, yet recognition is delayed. The absence of motion does not render the leopard invisible, but it significantly reduces the probability that the observer's attention will lock onto it as a discrete form. B. Trigger and context. The reduction in detectability is closely tied to how visual systems prioritize information. Both human and animal observers rely heavily on motion as an early detection signal. In environments where background elements are already dynamic, swaying vegetation, shifting light, irregular shadows, static forms are deprioritized. This context is especially pronounced during dawn and dusk, when contrast boundaries fluctuate rapidly. Under these conditions, visual systems allocate processing resources toward change rather than stability. A stationary body that does not introduce new motion signals is less likely to be categorized as relevant. Leopards appear to exploit this context by maintaining immobility precisely when motion cues would otherwise dominate detection. The behavior does not depend on concealment behind objects, but on remaining visually neutral within a noisy field. C. Adaptive function. Functionally, suppressing motion cues serves as an efficient method of reducing detection without additional energetic cost. Movement, even minimal, increases the likelihood of recognition by triggering attention mechanisms in observers. By eliminating movement entirely, the leopard lowers its salience within the visual field. This reduction in salience extends the time window before detection. The animal gains additional seconds or longer during which it can observe prey, assess risk, or wait for further changes in environmental conditions. In hunting contexts, delayed detection directly increases the probability of successful approach or ambush. Importantly, this advantage does not require the leopard to be closer to prey. It allows the animal to remain at a distance while maintaining low detectability. The behavior, therefore, enhances flexibility, enabling the predator to choose when to transition from observation to action. D. Limitation and trade-off. Reliance on the absence of motion introduces constraints. If background activity decreases, such as during still air or uniform lighting, the lack of motion becomes less effective. In these conditions, static forms may stand out more clearly against a stable background. Additionally, immobility reduces responsiveness to sudden changes. The animal must balance remaining still with maintaining readiness to react. Prolonged stillness can delay response time if unexpected threats emerge, or if prey alters trajectory rapidly. Despite these limitations, the persistence of this behavior suggests that the benefits of suppressing motion cues outweigh the costs under common environmental conditions. By aligning stillness with periods of visual complexity, leopards reduce detectability through a mechanism that depends not on hiding, but on how observers allocate attention. Surface properties and light interaction. A. Observable description. Under certain lighting conditions, leopards appear visually flatter than expected. In footage captured during early morning or late afternoon, the animal's coat retains its color and pattern, yet the body exhibits reduced surface relief. Muscular contours are less pronounced, and transitions between illuminated and shaded areas on the body appear softened. The leopard remains clearly present in the scene, but its three-dimensional form is less immediately readable. This effect is not constant. The same individual, recorded at different times of day, displays markedly different visual characteristics. Under overhead light, the animal's volume is clearly defined, with distinct internal shading and visible depth. Under low-angle light, these cues weaken. The change is situational rather than anatomical. B. Trigger and context. The interaction between surface properties and light angle is central to this behavior's effectiveness. Low-angle sunlight strikes the body laterally rather than from above, reducing the formation of internal shadows that normally define curvature and depth. In environments where background luminance is similar to the animal's coat, contrast between the body and its surroundings decreases further. The leopard's fur contributes to this interaction. Fur structure influences how light is reflected, scattered, or absorbed. When incoming light is absorbed rather than reflected back toward the observer, surface gradients become less distinct. This effect is amplified in habitats where surrounding surfaces, soil, bark, and leaf litter share similar absorptive qualities. These conditions are most likely to occur in forested or semi-forested landscapes during transitional lighting periods. The context does not eliminate visibility, but it reduces the visual cues that allow observers to interpret form and distance accurately. C. Adaptive function. Functionally, reduced surface relief decreases the reliability of depth perception. Observers rely on shading gradients to infer curvature and spatial orientation. When these gradients are weakened, the body is perceived as less volumetric. This does not prevent detection entirely, but it delays recognition and classification. For a predator that relies on proximity and timing, such delays are advantageous. Reduced depth clarity increases uncertainty about the animal's posture and distance, complicating assessment by prey and observers. The leopard can remain exposed while benefiting from diminished interpretability of its form. Importantly, this effect does not require specialized anatomical modification. It emerges from the interaction between existing surface properties and environmental lighting. As a result, the behavior remains flexible and does not constrain the animal to a narrow range of conditions. D. Limitation and trade-off. The effectiveness of this mechanism is limited by lighting stability. As the sun rises or sets further, changes in angle restore internal shading and depth cues. Additionally, backgrounds with strong contrast or uniform coloration reduce the benefit of surface absorption, making the animal's form more legible. There is also no guarantee that all observers experience the same degree of visual uncertainty. Species with different visual processing strategies may rely less on shading cues. Consequently, the advantage conferred by reduced surface relief is context-dependent and variable. Despite these constraints, The repeated alignment of surface-light interaction with periods of stillness suggests that the behavior contributes meaningfully to reduced detectability. It functions as a secondary mechanism that enhances the effectiveness of immobility by weakening depth cues rather than eliminating visibility. Information gathering during reduced detectability. A. Observable description. During periods of prolonged stillness, leopards do not disengage from their surroundings. Although the body remains motionless, subtle indicators of sensory monitoring persist. The head maintains a stable orientation toward open space, ears remain upright and responsive, and minor adjustments in posture suggest continuous awareness rather than inactivity. These observations indicate that the animal is not resting, but actively sampling its environment while remaining visually static. Camera trap footage often shows the leopard maintaining this state, while other animals move through the frame. The predator does not react immediately, even when potential prey is present. Instead, it continues to hold position, allowing the scene to change around it without contributing visual motion. B. Trigger and context. This behavior is most frequently observed when environmental conditions already favor reduced detectability. Low-angle light, fragmented backgrounds, and variable shadow patterns create a context in which visual recognition is delayed. Within this context, remaining motionless allows the leopard to collect information without increasing its visual footprint. The behavior commonly occurs at vantage points overlooking trails, clearings, or terrain transitions. These positions maximize sensory input while minimizing the need for movement. By selecting locations where information density is high, the leopard reduces the need for repositioning, which would otherwise introduce motion cues. C. Adaptive function. Functionally, stillness, under reduced detectability conditions, serves as an information-gathering phase. By remaining visually neutral, the leopard can observe prey behavior, assess group size, monitor movement patterns, and evaluate potential risks without triggering early detection. This increases decision quality before committing to action. From an evolutionary perspective, behaviors that improve information accuracy without increasing energetic cost are strongly favored. Movement not only expends energy but also increases the likelihood of detection. By decoupling information gathering from motion, the leopard gains a strategic advantage. It can delay commitment until conditions are optimal. This phase also allows the animal to synchronize its actions with external changes. Shifts in prey orientation, spacing, or distraction can be exploited once movement resumes. Stillness therefore functions not as an endpoint, but as a preparatory stage that enhances subsequent behavioral effectiveness. D. Limitation and trade-off. Extended information gathering through immobility carries risks. Remaining stationary limits the animal's ability to adjust rapidly to unexpected changes, such as sudden disturbances or shifts in wind direction that could reveal scent. Additionally, opportunities may be missed if prey moves beyond effective range while the leopard remains still. There is also a temporal constraint. The effectiveness of reduced detectability is tied to environmental conditions that change continuously. As light angles shift or background activity decreases, the benefit of stillness diminishes. The leopard must therefore balance information gain against the risk of losing favorable conditions. Despite these trade-offs, the repeated occurrence of this behavior suggests that the benefits of improved assessment and timing outweigh the costs. Stillness, when paired with reduced detectability, functions as a critical phase in optimizing decision-making rather than a passive delay. Risk management and detection thresholds. A. Observable description. In observational records, leopards maintaining prolonged stillness are rarely positioned in locations that would expose them to immediate threat. The animal typically selects sites that provide partial visual coverage while preserving escape routes. Even while remaining motionless, the leopard's posture suggests readiness. Limbs are positioned to allow rapid movement, and the body remains balanced rather than relaxed. Notably, when potential threats enter the scene, such as humans, larger competitors, or alert prey, the leopard does not always respond with immediate movement. Instead, it often maintains immobility until a clear change in detection likelihood occurs. Movement is delayed until the observer's proximity, orientation, or behavior indicates that remaining still no longer reduces risk. B. Trigger and context. This behavior is triggered by fluctuating detection thresholds rather than fixed danger signals. Detection threshold refers to the point at which an observer is likely to recognize and correctly identify the animal as a threat. Under low-angle light and visually complex backgrounds, this threshold is elevated. Observers require stronger cues, such as motion or contrast, to confirm presence. Leopards appear to exploit this elevated threshold by remaining still as long as visual ambiguity persists. The behavior is most common in environments where escape routes are available and where the cost of delayed movement remains low. If environmental conditions change, such as sudden noise, direct gaze from an observer, or improved lighting, the threshold drops and movement becomes necessary. C. Adaptive function. Functionally, this behavior allows the leopard to manage risk dynamically. By remaining motionless, the animal reduces the probability of triggering early detection while preserving the option to respond if conditions deteriorate. This strategy minimizes unnecessary flight responses, which are energetically costly and may expose the animal to additional threats. Risk management through stillness also supports coexistence with potential competitors and humans. Avoiding detection reduces the frequency of direct encounters, lowering the likelihood of conflict. In habitats where overlap with human activity is increasing, behaviors that reduce encounter rates without requiring relocation are particularly advantageous. From an adaptive standpoint, maintaining control over detection thresholds increases survival efficiency. The leopard does not react reflexively to all potential threats. Instead, it responds when detection becomes probable rather than merely possible. D. Limitation and trade-off. This strategy relies on accurate assessment of detection likelihood. Misjudging the threshold by remaining still too long or by moving too early can increase risk. Sudden changes in observer behavior or environmental conditions can rapidly undermine the effectiveness of immobility. Additionally, remaining motionless limits proactive avoidance. The animal must accept a degree of uncertainty while waiting for clearer signals. This introduces risk in environments where multiple observers or predators are present. Despite these limitations, the repeated use of stillness as a risk management tool suggests that the strategy effectively balances concealment with readiness. By adjusting behavior according to detection thresholds rather than fixed cues, leopards reduce unnecessary exposure while retaining the capacity for rapid response. Energy efficiency and behavioral economy. A. Observable description. Periods of stillness in leopards are often prolonged, yet they are not accompanied by signs of physical fatigue or recovery behavior. The animal does not shift into resting postures, nor does it disengage from its surroundings. Instead, the body remains structurally prepared for movement, indicating that immobility is not a consequence of exhaustion, but a deliberate behavioral state. Field observations show that these stationary phases frequently occur between bouts of movement rather than after them. The leopard may move into a position, remain motionless for an extended interval, and then either resume movement or initiate a rapid action. This pattern suggests that stillness is integrated into the behavioral sequence rather than serving as a pause for recuperation. B. Trigger and context. Energy expenditure is closely tied to environmental predictability. In complex habitats where prey movement is intermittent and detection conditions fluctuate, constant movement is inefficient. Stillness is most frequently adopted when environmental uncertainty is high, and immediate action would likely be premature. Low-angle lighting conditions further reinforce this context. During these periods, the energetic cost of moving, while simultaneously increasing detectability, outweighs the benefits of repositioning. By remaining stationary, the leopard conserves energy while waiting for conditions to improve, either through prey approach or changes in light and background activity. This behavior is less common in open environments where movement provides clearer informational gain. The context, therefore, determines whether energy conservation through stillness is advantageous. C. Adaptive function. From an adaptive perspective, stillness functions as an energy-efficient strategy that reduces unnecessary expenditure. Predation is energetically expensive, and unsuccessful pursuits carry significant costs. By minimizing movement during periods of low informational payoff, the leopard reduces wasted effort. Energy efficiency also supports longevity and reproductive success. Behaviors that conserve energy without compromising hunting success contribute to overall fitness. Stillness allows the leopard to allocate energy toward moments of high probability engagement rather than dispersing effort across uncertain opportunities. Importantly, this strategy does not reduce hunting capability. Instead, it refines timing. The leopard delays action until environmental and behavioral cues align, increasing the likelihood that any subsequent movement will yield a favorable outcome. D. Limitation and trade-off. Energy conservation through immobility carries opportunity costs. Remaining still may reduce the frequency of encounters with potential prey, particularly if prey movement is sparse. Additionally, prolonged inactivity may limit exploration of new hunting areas. There is also a trade-off between conserving energy and maintaining environmental awareness. Although stillness supports sensory monitoring, it restricts spatial repositioning, which may be necessary in rapidly changing contexts. Despite these constraints, the integration of stillness into the leopard's behavioral economy indicates that the benefits of reduced energy expenditure outweigh the risks. By treating movement as a selective investment rather than a constant state, the leopard increases overall efficiency in environments where uncertainty is high and timing is critical. Learning, consistency, and population-level patterns. A. Observable description. Across different regions and individuals, prolonged stillness under specific environmental conditions appears with notable consistency. Camera trap data from Sri Lanka and southern India show that this behavior is not confined to a single age group or sex. Adult males, females, and subadults all display similar patterns of immobility when light conditions and habitat structure align. The behavior is also repeatable within individuals. The same leopard may exhibit prolonged stillness at similar locations across multiple days or weeks, suggesting that the behavior is not situational improvisation. Instead, it follows a recognizable pattern that reappears under comparable circumstances. B. Trigger and context. Consistency across individuals raises the question of how this behavior is maintained within populations. Some components are likely innate. Stillness as a response to uncertainty is common among ambush predators. However, the precise timing and environmental alignment observed here suggest a role for learning and experience. Young leopards appear to refine this behavior over time. Early observations indicate that juveniles display shorter and less strategically timed periods of immobility. As individuals mature, stillness becomes longer and more closely synchronized with optimal environmental conditions, such as transitional light and visually complex backgrounds. This pattern implies that while the capacity for stillness is inherited, its effective deployment is shaped by experience. Environmental feedback reinforces successful timing, allowing the behavior to stabilize within populations. C. Adaptive function. From an adaptive standpoint, behaviors that combine inherited capacity with learned refinement are particularly resilient. They allow individuals to adjust to local conditions without requiring genetic change. In the case of leopards, stillness, aligned with reduced detectability, can be fine-tuned to specific habitats, prey species, and light regimes. At the population level, this flexibility supports persistence across diverse environments. Leopards inhabit a wide range of landscapes, from dense forests to semi-open terrain. A behavior that can be adjusted through learning rather than fixed anatomy allows the species to exploit similar perceptual gaps under different ecological contexts. This adaptability also reduces reliance on specialized traits. Instead of evolving new physical features, Leopards leverage existing sensory and behavioral capacities, increasing survival efficiency through behavioral plasticity. D. Limitation and trade-off. Learning-based behaviors introduce variability. Not all individuals achieve the same level of effectiveness, particularly in early life stages. This can increase vulnerability among juveniles and inexperienced animals. Additionally, reliance on learned timing means that rapid environmental changes such as habitat modification or altered light conditions may temporarily reduce behavioral effectiveness. There is also a risk of over-specialization. If individuals become too reliant on specific conditions, flexibility may decrease when those conditions are disrupted. However, the broad distribution of this behavior across populations suggests that such risks are mitigated by the behavior's inherent adaptability. Overall, the persistence of stillness-based strategies across individuals and regions indicates that the behavior functions as a stable, population-level solution to fluctuating detectability. It is neither purely instinctive nor entirely learned, but a combination that allows leopards to operate effectively within the limits of perception. Variation without narrative. When examining stillness-based strategies across different leopard populations, clear variations emerge without altering the underlying behavioral mechanism. The behavior itself, prolonged immobility under conditions of reduced detectability, remains consistent, but the contexts in which it is deployed differ according to environment. In dense forest habitats such as those found in Sri Lanka and parts of southern India, stillness is most frequently observed at forest edges, trail intersections, and areas where vegetation density fluctuates over short distances. These environments amplify background complexity and fragment light, making motion suppression particularly effective. Here, prolonged immobility tends to occur closer to open sightlines, where visibility exists but interpretability remains low. By contrast, in more open or semi-arid regions, leopards display shorter periods of stillness and rely more heavily on physical cover. Background complexity is reduced in these environments, and the visual field is less saturated with competing textures. As a result, immobility alone provides less benefit. Stillness remains present, but it is often paired with terrain features such as rocks, elevation changes, or partial vegetation rather than open exposure. Comparisons with other ambush predators further clarify the role of environment. Tigers, which inhabit denser vegetation, often rely on continuous cover rather than exposed stillness. Jaguars, operating in riverine and forested systems, display similar timing-based immobility, but tend to incorporate water or shadow-heavy substrates. In each case, the same functional principle applies, reducing detectability by aligning behavior with perceptual limitations shaped by habitat. These comparisons indicate that stillness is not a species-specific anomaly, but a flexible behavioral solution expressed differently across environments. The variation lies not in the behavior's purpose, but in how it is tuned to local conditions. This reinforces the conclusion that stillness-based concealment is an adaptive response shaped by environmental structure rather than narrative intent. Biological constraints. Why behavior has limits. Although stillness-based strategies provide clear advantages under certain conditions, they operate within strict biological constraints. No behavior can function independently of anatomy, physiology, and energetic limits. And immobility is no exception. From an anatomical perspective, prolonged stillness requires continuous muscular engagement. The leopard must maintain posture without fully relaxing skeletal support, which imposes a metabolic cost over time. While this cost is lower than that of sustained movement, it is not negligible. Extended immobility, therefore, cannot be maintained indefinitely without compromising readiness or endurance. Physiological constraints also shape the behavior's effectiveness. Sensory systems must remain active during stillness, particularly auditory and olfactory channels. Sustained attention carries cognitive and energetic demands, limiting how long the animal can remain in a heightened monitoring state. As fatigue accumulates, the risk of delayed response increases. Environmental conditions further restrict the behavior. Stillness is most effective under specific lighting and background configurations. Changes in wind, temperature, or ambient noise can rapidly undermine its benefits. For example, shifts in wind direction may enhance scent transmission, increasing the likelihood of detection regardless of visual ambiguity. Energetic trade-offs also impose limits. While immobility conserves energy relative to movement, it may reduce encounter rates with prey. In environments where prey density is low, remaining stationary for extended periods may be less advantageous than active searching. The behavior must therefore be balanced against ecological context. These constraints explain why stillness does not replace movement, but complements it. The behavior functions as one component within a broader behavioral repertoire, deployed selectively rather than continuously. Its persistence reflects not perfection, but adequacy, a solution that works often enough, under the right conditions, to be retained. Understanding these limits is essential. It highlights that the effectiveness of stillness-based concealment depends not on eliminating detectability, but on managing it within the boundaries imposed by biology and environment. Throughout this analysis, the behavior we examined was not extraordinary because it was dramatic, but because it was consistent. Stillness, when aligned with environmental conditions and perceptual limits, functions as a reliable way to reduce detectability without altering anatomy or increasing risk unnecessarily. What makes this behavior valuable is not that it hides the animal, but that it challenges how observation works. The leopard does not rely on concealment alone. It relies on timing, context, and the predictable ways in which visual systems prioritize information. Understanding this shifts attention away from spectacle and toward process. This perspective invites a broader question. How many other animal behaviors appear passive or insignificant, simply because their function is not immediately visible? And how often does misunderstanding arise from interpreting behavior through narrative rather than analysis? If one behavior can alter detectability without changing form, what other adaptations operate quietly at the edge of perception? Which animal behavior should we examine next, and what assumptions might it force us to reconsider?